In terms of state management, we have two different strategies, and both are implemented inside different commercial solvers and open source solvers. We have the copying strategy and we have the trading strategy. The copying strategy, whenever you want to save the state, will take all the objects that you have created inside the state management and store all the state of each of them and push this as a new backup inside the stack. And when you restore the state, you just pop the backup and restore all the objects that were created one by one. This is if you prefer a kind of brute force approach because you scan everything. The advantage of this is that it's more easy to do parallel computation because you did a complete clone of everything, then it's easier to do parallel computation. The trading system is more fine-grained. When you save the state, okay, it will just push the current backup on top of the stack and create a new empty backup. But this is only when you really want to change a new object and that you are about to realize that you will erase something that is important, that you will really store this very little modification that you do not want to lose. And so when you restore the state, you pop the backup and you restore its content, but it's possible that you don't need to restore all the complete set of objects because not all of them were modified since the previous backup. And so the advantage of this one is that it's more time and memory efficient because the amount of memory that you use between two backups is proportional to the number of objects and the number of changes that you did. While here, the time and the memory is proportional to the number of state objects that you have created so far. And so this is usually more efficient to implement, but this is also more difficult to parallelize or do distributed computation with this code because you don't have a complete clone of the system. So I propose now to show visually what are the differences. I won't show the implementation, but you can look into the slides and the source code if you want to look into the implementation. But I think that with the visual explanation, you will understand the different strategies, copying and trading. So on the left, I've got the copying strategy, and on the right, I've got the trading, what we call the trading strategy. And so on the left, I've got the trailer, and the right, the copier, or the opposite if you prefer. Okay, so it's two possible ways to instantiate an object of type state management. The two implement the same interface. Then I will create a state integer A and state integer B. Okay. Initially, they are equal to 7 and 13. And then I will save the state here. If you want to save the state, okay, in my two strategies, the copier and the trailer, I've got a stack of backups. Okay. And a backup is all the things that you need to restore when you will restore the state afterward. So in the eager strategy, the copier, when you save the state, you save the state of all the objects. So far I've got the object A and B created on the state manager, which means that I will save the state of A and B as they are currently. So A is equal to 7 and B is equal to 13. I will store that information. For the trailer, I do nothing. I have nothing in my backup. Okay? But when you save the state, you create a backup entry, but it contains nothing. Okay? So you can already see the difference here. I have two entries. Here I've got nothing. So I'm using less memory already. And I create a new backup here inside my trailer. When I do a save state, I push my previous backup and I create a new backup. Let's continue. I modify A to 6 and then I modify A to 11. Okay? I do not touch the value, the variable B. I don't touch it. I only change A. So when I do A is equal to 6, I realize with the trailer that I'm about to lose the information that it used to be 7. But I want to store that information because meanwhile, I did a save state. And so I really need to store, when I'm doing the set value 6, I really need to remember that it used to be 7. Otherwise, I won't be able to restore it if needed. So when I'm doing A equal to 6, I say, let's remember this, that A used to be 7, and I add that to the current backup. Then A equal to 11, okay, I do nothing. I don't need to remember that the value was 6. Because I didn't do any save state between the two, so there is no need. I I can afford to forget this value 6. Nothing there needs to be remembered, and it's the same here for the copier as well. So the next time you do save state, the current backup is added on top of the stack, and so you only need to store here a equal to 7. But for the copier, again, you do a complete scan of all the objects, A and B, and you restore the current value that they have. Okay? And here you need to remember A is equal to 11 and B is equal to 13. Okay? The current value that they have. And you see that B was copied, although it didn't change since the previous time. Now you change it to 4 and 9, A and B. And so since you are changing A and B, you need to remember that A is 11 and B is equal to 13. Otherwise, you will forget it. Okay? And so you have 2 entries there. And so next time you do save state, you add it. But here it's not what I did. I did a restore state. And so the restore state will simply pop the last backup and restore the value that they had before. So you will restore A is equal to 7. And here you will restore what they used to be. So you restore the current backup here. Like this. And so now what you have is A is equal to 11 and B is equal to 13. Okay? As it was just before you save the state. Okay? So that's really the difference between the two strategies. Again, the copier is scanning all the objects and creating a backup for each of them, and the trailer is different. It's more fine-grained. It will only store a new backup and create a new entry for restoration only if he realizes that he's about to forget a value that it needs to remember because someone asked it to be restorable. Okay, so that's the two different strategies. You can look into the implementation at your pace, at your own pace. I do not enter into the details because I don't think it's too important for what you need to do this afternoon. But you can read the class implementation. Everything is there inside the slides.